Welcome back, everyone. In this lecture, we're going to formally discuss Python comparison operators. And we actually mentioned these at the very end of your previous assessment test. Hopefully they were pretty straightforward, but in case they were a little confusing, now we're going to formally dive into them and show you how you can return back Boolean values using comparisons. Let's open up a Jupyter Notebook and get straight to it. All right, so here I am at a notebook, and before we get started, I want to briefly mention that in the comparison operators notebook that goes along with this lecture, it's underneath the comparison operators section, there's actually a table of comparison operators, same table from the previous assessment test that has the operator, the description, and then an example of it. So let's get started. Basically going to walk through all of them. Should be pretty straightforward. A little quick lecture here. Often you're going to want to check for equality. So to do that, it's just double equal signs. So 2 equals 2. Run that, and that's true. If we check it out on something else, for example, is 2 equal to 1, we get back false. And the reason we have 2 equal signs is because we don't want to use a single equal sign, otherwise Python's going to think you're trying to assign a variable there. And you can use this not just for numbers, but basically any objects. So I can check, is the string hello equal to by? And if I run that, it says false. And notice when you're comparing strings, capitalization counts. So you can't do something like this. And that returns false because one is lowercase b and one is uppercase b. And you should also be aware that Python is going to consider types. So for example, the string 2 is not going to be equal to the number 2 or the integer 2. For floating points, as long as they hold the same value, they will be true. So 2.0 is going to be the same as 2. So that's equality. For inequality, you can use the exclamation point equal sign. So if you're going to say, is 3 not equal to 3? Well, that's false because 3 is equal to 3. And let's show you an example of where it's going to return true. So is 4 not equal to 5? That returns true. So we have equality, we have non-equality or not equal. We also have greater than, so I can say is 2 greater than 1? That's true. Is 1 greater than 2? That's false. Then we have less than, so basically the reverse. Is 1 less than 2? That's true. Is 2 less than 5? That's also true. And then we have greater than or equal to and less than or equal to. So I can say is 2 greater than or equal to the number 2. In this case, it's true because they're equal to each other. And then we can do a similar thing. We can say is 4 less than or equal to, for example, 1, and that's false. And you can see a bunch of other comparisons right here in this notebook. Pretty straightforward stuff. A lot of times what we're really going to be using is the equality. But coming up next, what we want to discuss is if you want to make more than one comparison at a time. So far, we've just been comparing two numbers or two objects, so 2 and 2, 1 and 0. But often, you're going to want to do multiple comparisons on the same line. And to do that, we're going to use something called logical operators, which will allow us to chain together comparison operators. So we'll discuss that in the very next lecture. I'll see you there. Welcome back, everyone. In the previous lecture, we learned about comparison operators. Now we're going to discuss how to chain together different comparisons. And we can do this with the use of what are called logical operators, and they allow us to combine comparisons. And the key logical operators we're going to be discussing here is the AND keyword, the OR keyword, and the NOT keyword. So let's explore how to use these keywords, as well as chaining comparisons without the use of these keywords. All right, let's imagine that we wanted to have a condition that executed when we actually did two comparisons. For example, we wanted to check if 1 was less than 2, and we also wanted to check at the same time if 2 is less than 3. So you can imagine that instead of these direct numbers, we'd be using variable names that maybe get changed somewhere else in our code, but to keep things simple, we're just using direct integers. So to chain these two together, what we could do is do the following. We could say, is 1 less than 2, and is 2 less than 3? So when we run this, we get back true because this chain comparison is true and this comparison is true. If we were to change one of these, so for example, if I switch this to ask is 2 greater than 3, we get back false because even though this first one is true, this second one is no longer true. Now you could use this sort of chaining together, but alternatively, you can use a logical operator. And the one you would use to basically rewrite this code here is the AND keyword. So instead of the following from above, I could say, is 1 less than 2? and notice that syntax highlighting there, is 2 greater than 3. And that returns back false as well. And I could switch this to be less than, and then that returns true. So all the AND keyword says is, hey, is what's on my left true, and is what's on my right true? And remember, these could be any sort of comparisons. So I'm going to show you another example. We could do something like, is H equal to H, the string, and is 2 equal to 2? We run that together, and we get back true. Sometimes when people are writing out their code, they like to add in a little more organization by kind of wrapping these comparisons in parentheses, and you'll see me do that from time to time. For some people, this is a little more readable. For others, it's less readable because you're inserting more stuff. It's up to you whether you want to use these or not. There are certain libraries that we'll talk about later on that do require you to have these parentheses. But for now, it's basically up to you. If you think with the parentheses more readable, go ahead and use them. If you like it that it's a little kind of sleeker without the parentheses, you can go ahead and do that as well. But just keep in mind the AND keyword says it's what is on my left true and is what's on my right true. And then it returns a Boolean based off that. Okay, so pretty straightforward so far with the AND keyword. As you may have suspected, there's also an OR keyword that we mentioned previously, and that just needs one of the conditions to be true. So again, we'll use numbers. We'll say, is 1 equal to 1, or is 2 equal to 2? So we run that and we get back true. However, the OR only needs one of these conditions to be true. It just needs the one on the left or the one on the right to be true. So I can show you what I mean by that. I'm going to make one of these definitely not true, so 100 is not equal to 1. But if I run this again, notice my cell count, it still says it's true because it just needs one of them to be true. So is this statement true, or is this statement true? And if we make them both false, then finally we get back the false. So that's the basics of chaining comparison operators with the AND keyword and the OR keyword. And I would recommend that you use these keywords instead of doing something like this, because in my opinion, they're a little more readable. So we always want to stress readability in our code. It's especially good because later on, maybe you come back to your same code a month later, you're going to want to be able to easily read the code. So we just discussed AND and then the OR keyword logical operators. I finally want to discuss the NOT keyword. So to round out our discussion by showing you an example of the NOT keyword, that's NOT for not, it basically just asks you to return the opposite Boolean of what you just did. So I will construct this with an example first. So 1 is equal to 1, we know that's true. If we wanted to get, for some reason, the opposite Boolean off of that, I could do not, and then in parentheses, 1 equal to 1, and it'll return back false. Technically, you don't need these parentheses here, so you could just do something like this, not 1 equal to 1, and you also get back false. It's up to you what's more readable. But all not is doing is it's asking for the opposite Boolean of whatever was returned here. So for example, just to show you again, let's say 400 greater than 5,000. So that's false, but if I put a not in front of it, it's going to now ask for the opposite. So it's going to say true. So not sometimes useful when you're trying to write out your logic. It'll be a lot more obvious when we begin discussing control flow in the next section of the course, but keep this keyword in mind. At first, you won't be using it too often, but later on, you're going to see that sometimes bits and pieces of code become more readable with the not keyword instead of using something like the opposite, which, would have been just is 1 not equal to 1 there. All right, that's the basics of logical operators. Again, main things to realize here is the AND keyword needs both conditions to be true. The OR keyword needs just one or the other to be true. We'll see you at the next lecture.